Elon Musk just revealed this new insane motor. This new Tesla engine will destroy the EV industry, said Elon Musk. The electric motor is one of the most significant inventions ever devised by man, from physically changing how we think about the world to pointing the way forward. And now, Elon Musk has shown Tesla's ridiculous new motor. How it works will blow your mind. Let's take a closer look at the building of a Tesla electric powertrain, which Nikola Tesla created roughly 100 years ago. The stator and rotor are the first two critical components to consider. The rotor is a series of short-circuited conducting bars connected by end rings. A three-phase AC source powers the stator. The three-phase AC in the coils generates a magnetic field. The Tesla motor is a four-pole magnet. The magnetic field creates a current which rotates the rotor bars. The rotor speed, or RMS speed, typically lags behind the rotor speed in an induction motor. An induction motor is quite strong despite the lack of brushes in a permanent magnet. Induction motors are unique in that the frequency of the AC power supply determines their rotational speed. This indicates that the power supply's frequency may be altered to adjust the spinning speed of the wheel. Tesla's speed control is simple and dependable. Tesla motors may spin at speeds ranging from 0 to 18,000 revolutions per minute. A battery pack powers the induction motor. However, because the motor generates DC power, the source must be converted to AC power before it can be used. This is where the inverter comes in. The inverter not only converts DC to AC, but also alters the frequency of the AC power, allowing it to regulate the motor's speed. The inverter may adjust the motor output power by changing the amplitude of the AC motor. The inverter functions as the brain of the electric vehicle. The battery packs are made up of vast collections of regular lithium-ion battery cells similar to those seen in everyday life, which most people find surprising. These cells are linked in series and parallel to create the electricity needed to power the electric car. Glycol coolant is circulated between the cells via entwined metallic inner tubes. This is one idea that differentiates Tesla from other electric vehicle manufacturers. Instead of a few large cells, multiple small ones provide essential cooling. As a result, thermal hotspots are removed, resulting in an even temperature distribution across several compartments, increasing battery pack life. These cells are organized into detachable modules, totaling around 7,000 cells and 16 modules. The Tesla Model S Plaid is presently the best display of Tesla's engineering expertise, at least until the Roadster arrives. Teslas have always been quick, and the firm led by its top geek appears to be equally capable of pushing inside joke limits as it is at making real industry-changing improvements. It has been booming in elevating Tesla's performance to ridiculous new heights. It is the first Tesla with 3 electric motors, 2 in the back and 1 in the front, which are now permanent magnet synchronous AC machines. The Plaid carbon fiber sleeved rotors, or the engine's spinning portion, are brand new. A carbon fiber cover holds each rotor together, allowing for a rotary velocity of up to 20,000 RPM, which is approximately 25% faster than before. Due to the differing coefficients of thermal expansion between carbon and copper, Tesla says that the motor's copper wire must be coiled at incredibly high tension, resulting in a very effective electromagnetic field. Furthermore, the Plaid resolves an EV issue, particularly in cars with direct drive transmissions like Tesla, where power decreases significantly as speed climbs. Tesla claims that the Plaid retains 1,000 of its 1,020 horsepower until it reaches its top speed of 200 miles per hour. Despite having more power, the Plaid was 175 pounds lighter than the Model S Performance, which weighed 4,828 pounds. So, how does the vehicle perform? The Model S Plaid rushes down the quarter mile in a breathtakingly quick 9.25 seconds at 152.6 miles per hour, according to Motor Trend. After a hard launch, the time from 0 to 60 mph is barely 1.98 seconds. It's challenging since the Plaid moves so fast even before you notice what's happening. The yoke becomes light in your hands, your neck muscles strain as your helmeted head burrows into the headrest, and your surroundings blur into forms and colors as a quarter mile of pavement disappears beneath you. That's a beautiful accomplishment, even though the car can't currently hit 200 mph and can't be maintained since the drivetrain would be damaged if such a thing happened. Top speed limitations are something Tesla hopes to improve with the next Roadster, which is billed as the next paradigm breakthrough in EV performance technology. Tesla asked Model 3 reservation holders in the United States if they would accept a car with a battery made from LFP cells rather than the nickel cobalt aluminum oxide or NCA cells used in previous Model 3 sedans, which will be delivered in North America in September 2021. In addition, they're pursuing research and development of the new 4680 battery cells. The 4680 refers to the battery's diameter and height, which are 46 millimeters and 80 millimeters respectively. This relatively large size, along with promises of improved power density, is estimated to save up to 14% in costs, with fewer cells required to generate a full-size pack. A timeline for mass production is yet to be determined. Panasonic, on the other hand, told US media following its 2021 earnings report that it'll prioritize Tesla car supply while also speaking with other manufacturers. While the new technology has been hailed as a significant step forward in lowering the cost of entry for environmentally friendly autos, Tesla recently revealed that it had put plans to create a more affordable hatchback called the Model 2 on hold for the time being. To minimize costs and improve efficiency, 4680 batteries may still be put in existing Model 3 sedans, Model S sedans, Model Y SUVs, and Model X SUVs. Electric vehicles are reshaping the hypercar and racing performance environments. These revolutionary hypercars have pushed the engineering boundaries to the point where internal combustion engines have run out of steam. Consider the Hennessy Venom F5 and the Bugatti Chiron, which both reached top speeds without needing electric power. It took around 150 years for combustion engines to achieve these feats. However, in recent years, all-electric hypercars like the Lotus Evija and the Rimac Nevera have been developed, and they easily outperform Venom and Chiron in terms of power. Notably, the first-generation Tesla Roadster created the ground for it to happen, and Tesla must now make the next giant leap ahead and compete with its new competitors. Tesla chief designer Franz von Holzhausen presented an unusual update on the Tesla Roadster, which has been frequently postponed. Tesla is still working frenziedly on the electric hypercar, which will be an exciting flying aircraft according to the designer. According to Musk, Tesla plans to sell a SpaceX package that includes cold air thrusters all around the car to increase performance. According to him, the kit may reduce the time from 0 to 60 miles per hour to 1.1 seconds. Can you imagine? That'll be the fastest automobile ever built, and it'll be a record that very few will be able to break in a short period, if at all. While towing an 80,000-pound load may also benefit from the carbon-wrapped electric motor technology, this cutting-edge motor might also be used in the unofficially proposed Tesla electric aircraft. We can anticipate that the gap between Tesla and its rivals will continue to grow even more comprehensively with the development of better optimized batteries and this new plaid electric motor wrapped in carbon. We hadn't agreed anything about the new Tesla Roadster in over a year and believed it had been delayed again. The company has had a rough year due to chip shortages, and the Cybertruck, a priority, has been delayed. When asked about the Roadster's schedule in September 2021, Musk stated that it had been postponed until at least 2023. Furthermore, the CEO remarked that its arrival would be determined by the amount of drama Tesla encounters in 2022. Elon Musk also disclosed that the Tesla engineering team had shifted its attention to a platform for a next-generation electric vehicle that'll cost half as much as the Model Y platform. Tesla has been promising to produce more affordable electric cars for years, but the high demand for electric vehicles and inflation has caused prices to rise instead. Suppose the objective is to produce smaller electric vehicles in bulk at a lower cost. In that case, Tesla will undoubtedly develop a platform that enables the production of such vehicles, expanding the market for EVs. Let's hope for the best. If you enjoyed this video, then make sure to subscribe for more Tesla and Elon Musk content.